So today we are taking notes on solving systems of linear inequalities graphically on a graph paper. So what does systems mean? We've been working on systems all last week. What is a system? Come on, people. More than one equation. We're going to have more than one equation that we're going to put on the graph. What's an inequality? Less than or equal to, greater than or equal to. Those are our inequalities. And so, when we graph, what we're looking for is the overlapping region. That will be the answer to both, or all three, or all four of the equations that we're graphing. These two symbols are greater than and greater than or equal to. And when you have greater than, you're above the line. When you have less than, you're below the line. When you have the or equal to part, you have a solid line. When you don't have the or equal to, you have a dashed or dotted line. And do you remember your golden rule for inequalities? When you are solving an inequality, if you multiply or divide by a negative number to solve the inequality, you must flip the inequality. If you have not memorized that rule, you need to do that. Okay, let's look at example number 1. Example number 1 is already in y equals mx plus b form. So, do you know whether that's a greater than or less than sign? If not, you can look back to your front of your page. When I graph that, am I going to graph it above or below the line? Greater than means I'm going to be above the line, and has this part right here, so that means when I graph it, I'm going to graph a solid line. Do you remember how to graph? Over here on my graph paper, on the y-axis, I'm going to start my graph at -4 on the y-intercept. My slope is positive 2/3. That means from that point right there, I am going to count up 2 and right 3 to make a positive slope. So I'm going to go back over here to my y-intercept. I got the y-intercept right there. Up 2, right 3. Up 2, right 3. Now, if you are using your Cami notes, you would go to Shapes and select a line and make a solid line across your graph paper. And then, because it's a greater than, I'm going to shade above my line. Or you might want to shade above your line using your highlighter. Where's my highlighter? You might want to use your highlighter tool and shade all of this part in here with your highlighter tool. This next kind of line, it cannot be put in y equals mx plus b form because it doesn't have a y. Do you see that? The reason it doesn't have a y is because the slope is undefined. This is a vertical line. And so on the x-axis, the intercept is going to be at 2 on the x-axis because this is a vertical line. And because it doesn't have an or equal to, this is going to be a dashed or dotted line. This is the only line where I think about left and right instead of above and below. And so this is greater than, and so that would be this part of the graph. Now what got shaded in both times? This part right here, all of this part right here, got shaded in both times. If you're using your highlighter tool in Cami, you can adjust how dark it is shading in. And so this part right here is the answer. This part that got shaded in twice. Now, is this part right here, this point right here, is it in the part of the graph that got shaded in twice? Well, let's find out where it is on the graph. This is 3 and -2. Well, it's right on the line. Is the line solid or dotted? Solid means that point is included. This point right here is on the solid line. And so, yes, this is part of the solution. All of the points in this part right here and the part on this part of the line from here up are part of the solution. Is the point 2, 4 part of the solution? Well, it's on the line, but it's on a dotted line. And so that would be a no. Solid lines are part of the answer. Dotted lines are the boundary, but not included. What about the point 5, 1? Is it in the colored in part? What about the point 8, 1? It's right below my line. If it is real close to the line and you can't tell, I will show you how to figure that out, but we're going to focus on the graphing right now. If it's real close to the line and you can't tell, then you can figure it out algebraically. That part lesson comes next. Are you ready for the next example? Okay. This example is also written in y equals mx plus b form already, and so I just need to graph it. When I graph this one, because it has a or equal to, this is going to be solid, and it's less than, so it's going to be below the line. It's going to be a solid line, and I'm going to graph below it, but first I have to graph the line. Back to our beginning page, It is a solid line if it has the or equal to. Whether it's less than or greater than, it is a solid line when it has the or equal to part. So, we are going to start at positive 2. And my slope here is negative 3. To be able to count the slope, I need a fraction, so that's going to be like 3 over 1. That's equal to it's negative 3 over 1. That's equal to negative 3. And I'm going to count down because it's negative and right. Down 3, right 1. And I am going to connect my dots. You're going to use the cami shape that's a line. And I am going to go below the line. All that part is going to be my shaded in part for my first line. For my second line, I'm going to negative 3 on the y-axis, but there's no slope. What does it mean? What's the slope? The second line has a slope of 1, so I'm going to count up 1 and right 1. Up 1 and right 1. This does not have the or equal to sign, so this is going to be dotted or dashed, whichever word you'd like to use. And so this is going to be a dotted line or a dashed line, and this is greater than, so I'm going to go above the line. What got shaded in both times? This part over here. Up to and including the solid line. Up to but not including the dotted line. I think you can use your highlighting tool to color that part in. Are you having success with your Cami highlighting tool? Okay. Is the point negative 4, negative 4 in the shaded part? The shaded part, the part that was overlapping on the shading, is the answer. So, yes, that's in the shaded in part. Is the point 0, 3 in the shaded in part? Nope, it's just a little bit too high. 0, 2 was in, 0, 3 is out. 6 and 5. Not even close. Negative 2 and 3. Any point in the shaded in part and any point on the line from here up is part of the solution. Are you ready for the next example? This example is not in y equals mx plus b form, so guess what I have to do first? I need to put it in y equals mx plus b form. I need to put both of these equations in y equals mx plus b form so that I can graph it. That means I am solving for y. I need the y by itself. I need to subtract the 2x from both sides. Not just the 2, not just the x, but all of the 2x so that I can get it in y equals mx plus b form. I need the y by itself. What am I going to do to cancel out the 3? And when you divide everything. Some teachers draw the line all the way across and put just a 3 at the bottom. I like to do it this way so you don't forget that the 2 gets divided by the 3 and the 9 gets divided by the 3. How many times does 3 go into 9? So when I graph this, I'm going to graph a solid line. Greater than means that I'm going to graph above the line. A slope of negative 2/3 means I'm going to count down and right when I count my slope. But I'm going to start counting from positive 3 on the y-axis. On the y-axis, positive 3. Down 2, right 3. Down 2, right 3. And then I am going to be shading above my line. Here's the line. I hope it was supposed to be solid because that's what I just drew. Solid line above the line. Then I need to solve this one for y so that I can graph it. Subtract 2x from both sides to cancel that out. Now, the y has a negative sign in front of it. I have to divide by -1 to cancel out that sign, that negative sign right there. When you divide, not any time there's a negative number, but when you're dividing by a negative number, when it's negative number in the bottom, that flips the inequality sign. The y's cancel out, the negatives cancel out, and that's a -5. This is a greater than, so I'm going to shade above the line. This is or equal to, so it's going to be a solid line. The slope is 2, and I have to change that to a fraction, and so I'm going to be counting up and right from the -5 on the y-axis. I'm waiting a minute for those of you that are trying to get this part written down. To graph it, I'm going to start at -5 on the y-axis, and I'm going to go up 2 and right 1. And I am going to make a solid line, and I'm going to shade above the solid line. And then I am going to look and find the part that was shaded both times. Anything in this highlighted part is an answer to both of the original equations inequalities that I started with. So is the point 4, 2 in the double shaded area? Is the point 5, 9 in the double shaded area? The 0.6 and -1 is right here. It's on the blue line, but it's way down here, and the shaded area is way up there, and so that is not a part of both solutions. 0.1, 2, 3 is just above the line, so it is in the shaded area. Example number 4, once again, is not in y equals mx plus b form. So the first thing I need to do is put it in y equals mx plus b form. The golden rule of inequalities does not have to do with adding and subtracting. The golden rule of inequalities says when you multiply or divide by a negative number, that's when you switch the inequality. Doesn't say anything about adding and subtracting. So my slope here is -2. That's the same thing as -2/1. And so I will count down and right from +2 on the y-axis. So I'm going to count down and right. And so when I connect my dots, I'm going to have a negative slope line. This is a greater than sign, so I will be coloring above. It doesn't have the or equal to, so it's going to be a dashed or dotted line, whichever one you prefer to say. And above would be up here. My next line I need to solve for y. I need to cancel out the negative. I have divided by a negative number, so that is going to switch the inequality. The negatives are going to cancel, the negatives are going to cancel, and that's going to be a -3. This is a greater than sign, so I'm going to be above or equal to means a solid line. What's the slope? So I'm going to count up 1 and right 1 from -3. Up here on the graph, the y-intercept is -3. The slope is 1, so I go up 1, right 1. And this is going to be a solid line, and I'm going to be above the solid line. What part got shaded in 2 times? This one is already shaded for you, and you have to write down the equations. The other problems gave you equations, you made the graph. Here's the graph. What were the equations? So, let's start with this line right here. This line right here is horizontal. Do we know the slope of a horizontal line? Do you know that the slope is 0 for a horizontal line? And notice I didn't put the equal sign yet because I got to figure out whether it's greater than or less than. And so this is the y-intercept. From this line right here, is it shaded above the line or below the line? Above would be greater than. Is it a solid line? Now, that is not considered good form because what is 0 times x? 0. And what's 0 plus 1? And so this should be written like that. Okay, what about this line right here? Y. Well, before we get that, I like to draw the line first. So what is the y-intercept here? Positive 7. And I need to find a pretty point. Y'all help me because I'm having trouble with my bifocals. Right there. Now, pretty point is a word that I made up, but most of my students understood it real quick. A pretty point is a point that's right on the grid marks. So you've got to find a pretty point in order to be able to count the slope. And so the slope would be 1, 2, 3, 1, 2, 3, 4. And I did that twice to make sure that I have the correct slope. So what is the correct slope? Now, is this a positive slope or negative slope line? Now, here's the line. Are we shaded above or below the line? So I need a less than sign. Is the line dotted or solid? You see how you figure it all out? We have one more line. This line right here, here is the y-intercept. Negative 1. I need a pretty point. So the slope is 1, 2, 3, 1. 1, 2, 3, 1. 3 over 1 reduces to positive or negative line. As you go across the graph from left to right, it's going up, so it's positive. I'm not asking about the shading yet. Now I'm getting ready for the shading. Here's the line above or below the line. Okay, Sometimes it's hard to tell. Sometimes it's more left or right. But below the line, it starts with Y. So you're talking about where is Y the least or greater. So this would be below the line because I started down here at the bottom of the graph. So did I color in that part in the below? Below is less than. The line is solid. It's or equal to. That was so fun. We want to do a dozen of those kind of problems, right? And then our most favorite of all kinds of problems, a word problem. And this is going to be even more fun because it's an inequality word problem. But you start a word problem by defining your variables. Anna is trying to balance the time she needs to spend on homework and working. So what are our two variables? Homework and work. And she's balancing the time. How are we measuring this time? By hours. And we're just talking about, when it says a week, we're just talking about a week. Okay, so her homework takes at least 15 hours a week. At least 15 hours a week. Does that mean she's spending 5 hours on her homework? Or 10 hours on her homework? Or 18 hours or 20 hours? Yeah, but the whole thing is a week, so don't worry about a week. But how many hours? At least. Yes, but does at least mean less or more? It means starting at 15 and going up. That's what at least means. So her homework has to start at 15 and go up. Let's try again. Her homework has to be greater than or equal to 15 hours. Any of you spending greater than 15 hours on your homework? Okay, what about her work? Her work, no more than 20 hours a week. Does that mean she can work 30 hours a week? So that means the work has to be less than or equal to 20 hours. No more than means 20 is the top number. And then she has 28 hours a week for these two activities, right? Less than or greater than? Is it supposed to go over the 20 hours? It's supposed to stay less than the 20 hours a week. So, was that as hard as you expected? We have an assignment number 14 for you to complete with these kind of problems. I believe it will be easier for you to use Kami on this particular assignment, although you might want to have out a piece of paper if you need to solve for Y.